So here we have our first conditional probability question, in which we have a sack that contains 5 blue, 3 yellow, and 2 black balls. 2 balls are drawn from the sack without replacement, and we know that if the first ball drawn is yellow, what is the probability that the second ball drawn is black? Okay, so now what makes this a conditional probability question is that we're given a condition of something that's already happened. We're given the fact that the first ball that has been drawn, that's already yellow. So using that fact, using that condition, we have to find the probability that the second event, which is that the second ball being drawn is black, we have to find the probability that that's going to happen. Okay, so if we look at the answer for that question, this is how we set it out. So we use this sort of formula. So this vertical line here, that basically is denoting the conditional probability. So we're saying, what is the probability of getting a black ball given that the first ball drawn is already yellow? Okay, and how do we solve that? That's equal to the probability of getting a black and a yellow ball over the probability of just getting a yellow ball. Okay, so the probability of getting a black ball is 2 out of 10, right? Because we have 2 black balls out of a total of 10. 5 plus 30 plus 2 is equal to 10, so 2 out of 10. And then if we were to get a yellow ball, it would be 3 out of 9, because we have 3 yellow balls left, and since it's without replacement, we're not putting the balls back. So if one ball would have been taken out, then that's just gone. So now instead of 10 balls left, we have 9 balls left, and out of those 9 balls, 3 of them are yellow. So that's why we get 2 out of 10 times 3 out of 9. And then we divide that by the probability of getting just a yellow, which is 3 out of 10. If you put that all in your calculator, then you get this final result here, which is 2 over 9. That's the probability that the second ball being drawn is going to be black, given the fact that the first ball drawn is already yellow. Okay, similar question here. We have a group of 6 men and 8 women, and we have to make a committee of 2 people. Okay, now we're given the condition that a woman is already selected as the first member of the committee, and then using that condition, we have to find the probability that both the members are women, or in other words, the second person that's being chosen, we have to find the probability that that second person is also going to be a woman. So then it's the same sort of formula, it's the same sort of concept. I've just sorted out my working out in a bit of a different way. So the probability of getting both members women is again the same as probability of getting 2 women, or probability of getting a woman and a woman, or the probability of just getting a woman, right? So it's a bit more confusing in sort of way I've sorted it out, but the overall formula is still the same. It's the probability of A and B over probability of B, right? Let me just write that down. P, that is, it's the probability of A and B over probability of B. And just to show you guys clearly the conditional probability formula, that's equal to probability of A given B. That's what we write it as. Okay, so that's the overall formula, and that's what we're sort of doing in this question as well, right? So it's the probability of A and B, so it's the probability of getting a woman and a woman over the probability of just getting a woman, right? So again, it's without replacement, we're assuming, because if you already selected that person, you can't select the same person again, right? There has to be 2 people that are selected. So that's why it's 8 over 14 times 7 over 13. So there's 14 people first. You select one of them, there's 8, and there's 8 women. And then once you've selected that first woman already, there's 7 of them left out of a total of 13. So we times it by 7 over 13. Over the probability of getting a woman, again, that's just 8 over 14. Put that on your calculator, and you get that final answer of 7 over 13. Okay, last question here. Again, similar concept. A number is chosen from the first 28 positive integers, and we have to find the probability that the number is divisible by 3, given that it is divisible by 4. So that's what they've So what else to be up? If we set out the formula for this one, again, it's going to be the probability of divisible by 3, probability that the number is divisible by 3, given that it is already divisible by 4. Okay, so we just sorted that out already there. And again, we've shown the same formula. That is equal to the p divisible by 3 and divisible by 4 over the probability that it is just divisible by 4. So over here, what I've done is I've listed out all the numbers up to 28, the numbers that are divisible by 3, the numbers that are divisible by 4, and the numbers that are divisible by both. Okay, so these are all the numbers that are divisible by 3, these are all the numbers that are divisible by 4, and we can see that 12 is common in both of them, and 24 is common in both of them. Okay, so the numbers that are both divisible by 3 and 4 is 2, okay, out of the total 28 numbers. Now, the numbers that are divisible by 4 is 1, 2, 3, 4, 5, 6, 7. That's 7 over 28. Put that in your calculator, and you get your answer 2 over 7. Okay, so pretty simple stuff. Nothing too extraordinarily difficult there. The main concept is you need to realize that we're given a condition, and we need to figure out what that condition is. And once you figure that out, then we can use this formula that's applicable in all these sort of questions. Okay,